Welcome to Deepwater's talk for XR Rebels. My name's Linda, and together with Ned, we will be delivering this recorded talk. If you are not yet a member of XR, please watch our Deepwater talk for people who want to either join us or would like to collaborate with XR. This talk will cover the impacts and causes of flooding, the science behind our extreme weather, what Deepwater is all about and how to join us, and our Deepwater Rise in action for COP26 and how to get involved. But now a little about Deepwater. We are an outreach campaign aiming to highlight the government's failure to address the causes of extreme flooding and, just as importantly, to recruit new rebels by helping people to make the connection between global heating and the extreme rainfall that we are all experiencing. We have found that the talk can bring up lots of different thoughts and feelings. And it's important to remember that we are dealing with this together. And together, as XR, we demand that the government and those in power meet our three demands. There is not a moment to lose. I would like to begin by acknowledging that some of you may have already experienced being flooded or know someone who has, and how devastating that can be. Your insights and experiences are valuable to us. We hope that we can all work together to demand urgent action on the climate emergency, because this is the root cause of our extreme flooding. Global instances of heavy rain and flooding have risen dramatically over the last decade, with some scientists finding the rise as high as 50% across the world. In this first section, we're going to concentrate on the human impacts of flooding in the UK. It's important to remember that flooding has a devastating impact on people, wildlife, agriculture, and food security across the globe, and that people in parts of the global south are bearing the brunt of extreme weather events, including devastating flooding. Here in the UK, we're also experiencing more extreme flooding. A recent Met Office report warns that extended periods of heavy rain here are now 7 times more likely because of global heating than they were in 2013 to 2014. And in the last annual Met Office State of the UK Climate Report, published the 28th of July 2021, 2020 was the first year to figure in the top 10 for rainfall, heat, and hours of sunshine in records stretching back a century. Here are some headlines. There are more, but we don't have to cover all the extreme rainfall events from July 2021. The point is that we hear about the ones that are on our doorstep in the UK and Europe. And sadly, the fact is that these events are competing for the headlines, but because of the increase in severity and frequency, there's too many to cover. They only make the news if the loss of life is great, or if they have a video that shows something drastic or unusual, such as the tube flooding in China, or more recently in New York. Many global heating-driven extreme weather events, such as heat waves, heavy rainfall, and coastal flooding, are highly likely to get more extreme, both in frequency and intensity, leading to greater loss of life and an increased damage to infrastructures. Hurricanes will become stronger and more damaging as warmer oceans result in more powerful storms, with higher wind speeds and bigger storm surges, as recently seen in the United States. The intensity of the most severe storms is projected to increase by the end of the century by 85% globally and 136% in the Atlantic basin. In addition, changes in the jet stream are causing storms to stall in one place, causing even greater devastation. If greenhouse gas emissions continue to increase, worldwide, 340 million or more people living in coastal areas will be threatened by flooding by 2050. In the UK, the climate emergency is expressing itself as flooding, catastrophic, life-threatening flooding. But in fact, what we are all dealing with is the destruction of global weather systems. Other parts of the world are facing the loss of normal wet seasons, causing drought, crop failures, and runaway fires. Flooding can result from sea level rise and storm surges, reservoir collapse, river flooding, and flash flooding. The most significant source of flooding today is river flooding, contributing 40% of total UK expected annual damage. Coastal flooding contributes 24%, surface water 20%, and groundwater 16%. But before we go any further, we're going to look at what it's like to be flooded. And for anyone who hasn't had to deal with flooding firsthand, this part can be quite shocking, because flooding has a deep and long-term impact, repeated flooding even more so. Being flooded is a matter of survival. Everything about your life can be destroyed and disrupted, and it can take years to regain some semblance of normal. Some parts of your own life will be lost forever. The impact of flooding is destructive, terrifying, and life-threatening. We're now going to look in detail at some of the impacts of flooding. The immediate impacts may be drowning through underestimating the depth of the floodwater or driving into water or being swept away, being injured by collapsed or unstable buildings and roads or hidden debris in the water, electrical injuries from damaged but live power cables and infrastructures, explosions from fractured pipes and storage tanks. Propane, for instance, spreads flames across the surface of the water. Hypothermia and failed infrastructure such as roads, bridges, rail, gas, electricity, or clean water may no longer be available. The midterm impacts include water contamination from sewage, chemical overspills from factories and farm effluents, carbon monoxide poisoning from unventilated generators, house fires caused by lit candles, communicable diseases spread in emergency shelters, diseases from contaminated water, vector-borne diseases from stagnant standing water, respiratory diseases from mold in houses, and animal displacements such as rats. Longer-term impacts can be disabilities from injuries, from not being able to get treatment or having resulting infections, mental health problems, social disruption causing crime and looting, disruption of infrastructure, which may affect your travel and access to amenities or work or school, poverty, your house value would be down and possibly your house would be uninsurable. You may have lost cherished items and pets. It may take months or even years to fully repair your home. And there's likely to be a loss of community if it has been devastated by flooding. And don't forget that flooding can happen more than once.
Pictures filmed on a drone show flooding up to the roof of Kevin and Catherine Lorriman's bungalow in the town of Snaith.
It's just been heartbreaking. We're going to have to demolish, I think. So that's gone. We're up to the gutter line, as you've said. And, you know, it's just, I can't even explain.
This video showed people who were experiencing floodwaters from the River Aire consuming their home in Snaith in Yorkshire. Days of rain had left an area the size of Lake Windermere underwater. I just want to emphasise the fact that there is a fourfold increase in psychological distress and the suicide rate 13.8% higher than pre-disaster rates. These mental health impacts may be from physical health problems, personal losses, social disruption, and economic hardship. Imagine knowing that's going to happen again and again and again. This has probably been uncomfortable listening, but flooding is climate change. In the UK, extreme and prolonged rain is our equivalent of the horrendous forest fires and devastating droughts that we've seen in other parts of the world. We've followed those horrors on the news and failed to see our own. After all, rain's normal in the UK, isn't it? And the appalling thing is that it is entirely down to us. And now we're going to look at the truth about the climate and ecological emergency, and I'm going to pass you over to Ned.
The thing is that it's all connected. Drought, extreme rainfall, prolonged rainfall, extreme snowfall, rising sea levels, and stalled weather patterns. The intensity of rainfall depends on how much water the air can hold at any given time. Rising air temperatures increase the evaporation rate, so our oceans release more water vapour into the air. And air can hold up to 7% more moisture for every 1 degree centigrade of temperature rise. February 2020 was the UK's wettest February on record in a series dating back to 1862. England, Wales and Northern Ireland all saw their wettest February on record, with Scotland seeing its second wettest. Rainfall was more than twice the average quite widely across the regions. Some areas, including Lancashire and West Yorkshire, where I live, recorded more than 3 times the average, and locally, some areas saw more than 4 times their normal February rainfall. Dr. Mark McCarthy, head of the Met Office's National Climate Information Centre, said, "We have seen a number of exceptionally wet winters in the last decade, and due to climate change, we expect UK winters to become wetter. Of the top 10 wettest winters, 4 have occurred since 2007 and 7 since 1990, whilst there's been a 17% increase in the total rainfall from extremely wet days." So what was recently regarded as rare flood events likely to occur once every 50 or 100 years are now becoming the new normal, thanks to global heating. This is a map that shows the areas of England at risk from river and tidal flooding. But remember that any location with a largely impervious surface, such as an urban area, is at risk from flash flooding. Flooding has always been an occasional part of life in the areas shown on the map, but experts warn that climate change is worsening the situation. In early 2019, Environment Agency Chairwoman Emma Howard-Boyd said that some communities might eventually have to move entirely. She added that we can't win a war against water by building away climate change with infinitely high flood defences. More than 3,400 of England's high consequence flood control measures, which is defined as those where there is a high risk to life and property if they fail, were judged to be in such bad condition they were almost useless. And remember, that's from the Environment Agency. Government calculations compare the cost of flood defences with the value of what is being protected. So to be funded flood defences must avoid £8 worth of damage for every £1 spent. But in practice, that means that cities with dense populations and high economic values, they benefit, whilst rural areas with fewer homes and businesses do not. And in fact, damage to farmland is not even factored in. Currently, there are 520,000 properties in England in areas at risk from coastal flooding, and there are 8,900 properties in areas at risk of being lost through coastal erosion. The total value of assets at risk from coastal flooding is estimated to be £120 to £150 billion. By the 2080s, 1.5 million properties, including 1.2 million homes, may be at risk of coastal flooding, with a further 100,000 at risk from coastal erosion. By 2100, around 1,600 kilometres of road, 92 railway stations, and 12 substations and nuclear power stations could be at risk from coastal erosion or flooding. On this slide, we're comparing the flood risk map to regional food production, because one of the biggest impacts of flooding, which is likely to affect us all in the near future, thanks to the global food supply chains, is crop failure. Food production in the UK and globally has been affected over the past 30 years. The food imported to the UK from overseas represents about 45% of our consumption, which means that our own food security is now a big issue. As an example, some cereal yields in the UK have decreased by 38% in 2020. And this was due to prolonged rainfall and flooding at the usual time of sowing in the spring, which led to low germination. And then this was followed by prolonged and persistent heat and dryness towards the summer months, which then stopped the crops from thriving. The proportion of fresh fruit and vegetables imported from climate vulnerable countries, in other words, those worst hit by climate breakdown, increased from 20% to 32% over the last 2 decades. Now, as we said earlier, most flooding occurs due to sea level rise, storm surge, rivers breaking their banks, flash flooding, and groundwater levels rising. But one other, thankfully less frequent, but massively more devastating cause of flooding is reservoir collapse. Both the increased volume of water entering the reservoirs and a failure to design for climate change has resulted in spillways not having sufficient capacity to release water before the reservoir is overtopped. And this overspill can destroy the dam wall and the spillway, which can then engulf communities downstream. Scientists warn that aging dams will increasingly fail as climate change makes extreme rainfall and storms more frequent and intense. This Environment Agency map shows where the sewage network discharges treated effluent, untreated effluent, and stormwater into rivers. Such discharges are permitted under certain circumstances, such as when infrastructure is unable to cope with surges in sewage and wastewater, often caused by additional flows from wet weather. Such discharges are known as combined sewer overflows, or CSOs, and that's what I'm going to use as a term from now on. And the Environment Agency is responsible for issuing these discharge permits. However, water companies are not required by law to report on all types of CSOs. In 2019, reports show that raw sewage was discharged into English rivers on over 400,000 occasions, but this is only part of the picture. Not all discharges are monitored, and a single event may vary in length from a few hours to several days. CSOs into low or no amenity waters occurring fewer than 20 times per year require no form of event monitoring. Treating wastewater removes about 90% of microplastics. Researchers at the University of Manchester, though, found that the poor management of untreated wastewater and raw sewage by water companies was the main source of microplastic pollution in the UK's rivers. The presence of high levels of microplastics on the riverbed suggested that water companies were also spilling raw effluent during dry spells, and that is against UK and EU regulations. If you add to all of this industrial, agricultural and urban runoffs, as well as pollution from roads, so things like dust from brake discs or tyres, they all get added to the pollution. And then toxic metals and hydrocarbons found in fuel and other pollutants washed into water pose a significant threat to river health. Road runoff can carry over 300 pollutants, causing short and long-term damage, including killing fish and even discolouring water, turning the rivers black in areas of heavy traffic. According to the Rivers Trust, only 14, that's 14% of rivers in England are considered to have a good ecological status within the Water Framework Directive. The most unpredictable and dangerous type of flooding is flash flooding. In the picture on the left, you can see that natural ground cover can allow 25% of rain to sink into the topsoil, 25% into the deep aquifers and water table, 40% evaporates or is drawn into trees and transpired, and only 10% forms runoff and travels to our drainage systems. But on the right, in built-up areas where 75 to 100% of the surface is impervious, 15% is drawn into the ground, 30% evaporates, and 55% will run off. And that overwhelms our drainage systems and causes flash flooding. And here we're going to now look at landfills. 1,264 historic landfill sites are located in coastal areas and estuaries at risk from erosion. And another 2,964 sites are located in floodplains. Landfill sites before the mid-1990s had few or no restrictions about what rubbish could be dumped in them, and so little is known about what they contain. But many were on the coast, and some were used to raise land levels and even used as part of flood defences. Climate change is bringing higher sea levels and stronger storms, and so they are putting the old dumps at greater risk of being broken up. The Environment Agency assessed 2 landfill sites in Essex to find out the level of toxic pollutants in the waste they contained. It found large quantities of harmful metals, such as lead and polycyclic aromatic hydrocarbons, PAHs, and these are carcinogenic. The Climate Change Commission says, our flood defence plans cannot be relied on to reduce the risks from coastal flooding and erosion. And this is because these plans are not legally binding and they contain unfunded proposals. Implementing current policies to protect England's coast would cost 18 to 30 billion pounds in total. The degradation and disturbance of naturally occurring wetlands is a major cause of increased carbon emissions. And yet, wetland areas in the form of fen, marsh, swamp and bog have been devastated. 90% of England's floodplains no longer function properly, with 65% modified by agriculture, meaning they're smoother surfaces, and so they're likely to be washed away and cause flash floods. 9% have been lost to urban and suburban building developments, 4% are now occupied by open water, and 6% by semi-natural woodland and rough grassland. And only 0.5% is now natural or semi-natural wetland. And all wetlands are capable of sequestering and storing carbon through photosynthesis and accumulation of organic matter in soils, sediments, and plant biomass. Sand dunes, mudflats, and salt marshes, which are native to the UK, are all effective at protecting the coast from flooding and erosion. They do this by decreasing the ocean's wave energy near the coast and on land, and by absorbing excess rainwater during times of heavy rain. The UK's extensive salt marshes have been shown to reduce wave height by up to 80% and prevent soil erosion.
So what's causing this extreme weather? The Greenland Ice Sheet contains enough stored water to raise sea level by more than 24 feet, or 7.2 metres, as it melts. How fast that will occur is one of the big unknowns for predicting the pace of sea level rise over the rest of the century. Glacial experts think the ice sheet was likely in balance in the decades leading up to 1990, but since then it's been losing mass at an accelerating pace. Adapted from the 2019 Arctic report card, this graph shows month-to-month changes in Greenland ice mass from April 2002 to April 2019. Each peak in the graph shows snow mass gained during the winter. Each valley shows the summer losses through surface melting and glacier thinning and retreat. The 17-year trend is estimated to be enough to have raised sea level rise by 12 millimetres or 1/2 of an inch. Here is an illustration of what's happening in the Arctic. Normally, snow and ice reflects the sun's radiation back into space. The sea is darker than ice, and so it absorbs the heat from the sun, prompting more ice melt and rising sea levels. This feedback loop is why the Arctic is heating up much faster than the rest of the planet. According to NASA, the Greenland ice sheet is rapidly melting and has lost 3.8 trillion tons of ice between 1992 and 2018. A positive feedback mechanism is a small change that creates an effect that results in a bigger change. This is why the ice melt in Greenland is accelerating. The Albedo Effect is the ability of the surface to reflect the sun's rays. Here you can see that snow reflects 90%, soil 40%, and the ocean just 10%. Normally, snow and ice reflect the sun's radiation back into space, but as it melts, the darker soil and ocean absorbs the heat, and this causes rising surface and sea temperatures and more ice melt. A warmer sea expands and contributes to rising sea levels. The area of ice already lost is approximately the size of France. I'll give you just a few seconds to read this. This polar warming narrows the temperature difference between the Arctic and lower latitudes. And this is crucial because it's the temperature gradient between them that drives the jet stream. This is a wind which streaks around the pole at up to 250 miles per hour and about 8 kilometers above the surface. The jet stream forms a boundary between the cold north and the warmer south. But the lower temperature difference means the winds are now weaker, so the jet stream now meanders more, with big loops bringing warm air to the frozen north and cold air to the warmer south. Researchers say the changes can cause loops to remain stuck over regions for weeks rather than being blown westward as in the past. This blocking effect means extreme events can unfold, such as conveyor belt storms. It is this mechanism that gives us a month's rain in a day. Climate projections predict that the type of rain will change. Winter rain will come from high-intensity frontal events. Summer rain will come from short-lived high-intensity rain. High-intensity rain is harder for our infrastructure to cope with. A recent Met Office report warns that an extended period of heavy rain here, as in 2013-2014, when 10,000 homes were flooded, is now 7 times more likely because of global heating. Sea level rise is driven by ice melt and the expansion of the seawater as the temperature increases. This graph shows NASA satellite observations of sea level rise. Global sea level rise is accelerating incrementally over time rather than increasing at a steady rate as previously thought. And even if we drastically reduce greenhouse gas emissions, staving off 2 degrees C of warming, global average sea levels could still rise by 2 to 3 feet, or 30 to 60 centimetres above current levels by 2100. And higher sea levels give storm surges a higher starting point, increasing their size and their reach when they make landfall. Here is an image that shows how high tides and storm surges magnify the risk of sea level rise. The UK is one of the most vulnerable European countries to sea level rise. 69% of GDP is located within 50 kilometres of the coast, and 78% of the country's population live within this zone. At present, 414,000 people are exposed to sea level rise in the UK. Development on the coast has not always taken long-term sustainability into account, and natural environments that are resilient to change have been altered by the construction of hard coastal defences. Many coastal communities are particularly vulnerable because populations in coastal areas are often poorer and older than the UK average. The reality is that we currently have 1.2 degrees C of warming. Our record temperatures and record floods are not anomalies, they are the new norm. We are running out of time to reduce our carbon emissions fast enough to prevent much more damaging global temperature increases, but this is still possible if governments around the world act now with urgency. And the global carbon dioxide emissions fell by 6.4% in 2020 due to COVID. And if we are to limit global temperatures to 1.5 degrees, we need to drop emissions by 7.6% every year until 2030. And here's the truth, we are being failed. Here is a chart which shows our likely degree of warming against various scenarios. Emissions are shown on the vertical axis and decades along the horizontal. The single green line on the left shows from 1990 to present. Our target of 1.5 degrees is the turquoise pathway. For every year we delay the drop in emissions that are required to get us to 1.5 degrees, the gradient becomes steeper and harder to achieve. Likewise, the 2-degree purple line. Our pledges, represented by the yellow line, are being overshot, and even if met, would take us to 2.5 to 2.8 degrees. At 2 degrees, coral reefs will have been destroyed, crop yields will be decimated, and we will lose round-year polar ice, unleashing devastating weather and food poverty. Our current policies, represented by the orange band, are driving us towards 2.8 to 3.2 degrees. At 3 degrees Celsius, according to the IPCC, oceans will be an average of 3 feet higher by the year 2100. Those rising sea levels will have displaced 680 million people in low-lying coastal zones, along with 65 million citizens of small island states. The pink band shows where we would be if no action is taken. 1.5 degrees of warming are not going to be achieved if we don't act now, as if it's an emergency. And for every year we fail, a steep decline in the level of changes needs to be increased if we are to achieve those targets. It's important to remember that the rise in global temperatures is an average rise. Some parts of the planet will warm at a faster rate. The strongest warming is happening in the Arctic in the cooler seasons and in the mid-latitudes during the warmer seasons. According to NASA, some regions have already passed 1.5 degrees. Nothing's worked. Since the formation of the IPCC in 1988, we have knowingly emitted more CO2 than all our previous emissions. There are no signs that this is changing. The orange line started to rise approximately 220 years ago at the beginning of the Industrial Revolution, which is when we began burning fossil fuels on an industrial scale. And despite all targets, protocols, pledges, and agreements, it's just got worse. When people tell you that we're making progress, remember this graph. If this graph keeps on going up, then we are failing. No matter how many things they say we are doing, we cannot ignore the fact that we are way off track in tackling this problem. It's easy to feel nothing but despair, but this is where XR deep water wades in. So now we're going to look at deep water itself. We ask one simple question. You walk into your house and find water pouring through the ceiling. What's most important, catch the water or turn off the taps? This is our simple dilemma. Getting a bucket is a short-term measure and won't stop the damage. We need to turn off the taps, in other words, stop the cause of the flood and then deal with the consequences. We must demand that governments tell the truth, act now, and go beyond politics in order to achieve this. Since prehistory, rivers and the sea have been part of our lives and shaped our communities. We have settled at crossing places, traded and transported goods, fished, lived on rivers, travelled along them, and used them as places of leisure and sport. Rivers don't follow political boundaries. And political power is focused on our major areas of population and their tapestry of consumption. Our natural landscapes are a commodity. The Environment Agency has adopted a bioregional approach where our waterways are managed by a river basin catchment area. They used to be called watersheds. We have decided to organise deep water by river basin catchment area, and this is how it works. River basins start at the source and end at the sea. On the left, we have a UK map with regions and counties. And on the right, we have river basin catchment areas. You can see that they're quite different. The Environment Agency will collaborate with other water management authorities and charities in order to manage a river basin catchment area. There is another go at orientating us. On the left, we have the river basin catchment areas in colour with the regions overlaid. For reference, on the map right is a map with regions, towns and cities. Issues up and downstream are more relevant to a person facing extreme weather and flooding than those within a similar parliamentary constituency. To make it easier, deep water will have river basin catchment areas coordinators who will coordinate within the catchment area and work as a team across the UK. And we have researchers who will take on analysing the detailed boundaries and develop a deep understanding of their particular catchment area. And here are our objectives: to tell the truth and encourage people to connect extreme weather events, including flooding, with a climate emergency, to demand that governments, fossil fuel industries and their funders act now to turn off the carbon emission tap in order to prevent further climate breakdown, to give a voice to communities from rivers, sources to sea, connecting their experiences of the management of extreme flooding, and to use movement of movements and outreach to raise awareness of the root causes of extreme weather events, and then collectively pressure our government to support the CEE bill, making this a major issue for all candidates at all elections. Here you can see the deep water bubble for the UK. The dark blue circles each specialise in deep water issues and collaborate within the bigger deep water bubble, but they can also draw on the expertise from XR regions and from XR national. Deep water is deeply embedded within XR, and as you can see, the outer edge is open, allowing for collaboration. Our research group is our knowledge bank that will give others groups support. Talks and training are a team of people ready to give this talk. We have talks for non-rebels, rebels, and other movements. We've also separated out the talk into a series of 6 smaller themed sections. These sections are available in video format to add to the Deep Water campaign page or the XR UK website for the public to access or for rebels to share with others. Outreach is spreading the message and drawing more people into XR. Creatives is a group for artists, makers, writers, poets, singers, and will help us to reach the heart of the public. Political engagement is holding politicians to account and will facilitate people's assemblies on flooding issues. Media and messaging is developing our messages and getting the word out. River basin catchment area coordinators are coordinating with each other across the UK and representing the river basin catchment area's particular issues. And the anchor circle is holding the overview and steering the bubble towards more exciting possibilities. Some groups will have long-term steady activity, for example, research or talks and training. Other groups will have focused episodes of activity, e.g. actions or creatives. If anyone here would like to get involved or hear more about the roles and the groups, please speak to us after the talk. This is an example of the kind of training and support that already exists within XR, and deep water rebels are encouraged to learn new skills as well as using old ones. And here are some photographs of some of our recent actions. You can see examples of the posters that were developed for the election pack for the May 21 elections. This also included example letters and how to spot greenwash examples so that people could write to prospective candidates and use them at hustings. You can also see our stalls that were held in the Ludlow Green Festival and during the Impossible Rebellion, and another action which took place in Malvern last year. Here are things that we won't do. The first one is ambulance chase. As individuals or XR local groups known to residents in an area who are experiencing flooding, it's fine to turn up to offer help. But we must be very careful not to make capital out of someone else's disaster. Even our very best intentions can be willfully misunderstood by the media. Deep Water is an outreach and campaign group, and with our objectives clearly in mind, our role is to raise awareness, recruit rebels, grow alliances with like-minded organisations, and take actions to support all of this. Only this way can we demand action to turn off the taps. The other is local solutions. We won't get involved in local controversies about flood management solutions. There are many local flood action groups, and demands for responses to prevent future floods can be controversial and simply shift the water along to the next community. Equally, large private projects may be thinly veiled investment opportunities. We believe the answer to these emotive and controversial issues are people's assemblies.